Hello everyone, I'm David from the Underfloor heating store. We're on site today in a new build. We're going to be installing a high output ProCrate system. As you can see, we've got a bespoke design for the section of the build that we're going to be installing today. Once we get inside, the first thing we're going to do is we're going to fit our edge insulation around the perimeter walls. This is going to help to prevent heat loss into the block work. Once we've installed the edge insulation, we're then going to proceed to install our ProCrates. Once the ProCrates are in situ, we're going to move on to mounting our manifold. Once the manifold's installed, we can then proceed to fit our Per Evo PERT pipework. So we've installed our edge insulation now. We're going to get ready to install our egg crate. This particular one is the ProCrate. As you can see, it has two different profiles. The idea being that these will interlock with each other. The larger nodules should always be facing where you're starting from, with the smaller modules facing the next panel that you're going to interlock onto. So if you do have an edge insulation like we have with the apron, this is particularly important when you're having a liquid screed. The crate must sit on top of the apron, and this will stop the screed from getting behind and lifting the insulation up later on. So as you can see, we've got the first one installed. Now I'm going to demonstrate how the next one will interlock. It's inevitable you're going to have to cut the panel at some stage, especially around the edges of the room and into corners. So to do this, simply take your measurement, mark it on there, flip the panel over, and then simply cut through from the back with a simple Stanley knife. Like so. The manifold has 4 holes, so you'll notice on the wall we've already marked and pre-drilled the positions for our fixings. The plugs are already into the solid wall. We've come approximately ½ a metre off the ground, as that's the optimum height for the manifold. So I'm just going to quickly get this installed, and then we'll be ready for installing our pipework. Now there is a little bit of play on the bracket, so at this stage it's a good idea to get a level, make sure it's going to end up nice and straight. Uninstalled manifold. We're back for day 2 on site. We're just about to start installing our pipework. You might notice that there's this massive contraption by my side. This is actually called a pipe decoiler. So this particular model can handle pipe up to 500 meters in length. It's fully collapsible. It can be easily transported between jobs, and once it's all packed down, fits into this handy carry bag. Okay, so as you can see, we've laid the first circuit. So let's just quickly refer back to our installation plan. So as you can see, it's laid in a snail shell or if you want to be technical, a spiral counterflow laying pattern. And what counterflow means is that you've always got the hottest part of the circuit next to the coolest part of the circuit. And this ensures that you've got an even distribution of heat the whole way across. So we're now getting to the point where we are going to connect the last of the circuits up to the manifold. Obviously these ones have been done already, but this one is going to be for the purpose of demonstration and showing you guys how you go about doing it. So first of all, the first thing you're going to need to do once you've got all of your pipe run back to where the manifold's going to go is you're going to need to cut it all to the correct length. So let me just show you how easy it is to cut the pipe and what tool you need to use. So right here we've got just a standard set of pipe cutters. They're very sharp, so make sure that when you're not using them, you close them using this little silver latch. So here we are, one set of pipe cutters. Let's take this off, cut a pipe just to show you how this works. So that's how you cut the pipe. So as you can see, we've already cut all of these to the correct length. So we're just going to crack on and just show you what the next bit is. So before you connect the pipe to the manifold, you're going to need to do what's called re-rounding. So as you cut the pipe, if your blades are quite dull, or if it's a well-worn tool, you can sort of misshape the pipe due to the squashing action that happens. So what you do is you take your re-rounding tool. We're using a 16mm pipe, so this is 16mm end of the re-rounding tool. It's going to push this into the pipe, and you'll notice that there's a couple of blades on the shoulder of the re-rounding tool, and as you turn it, it will create a chamfer ready to receive your compression fitting. So we're just going to put a bit of pipe conduit on here just to protect it for when the screeders come in after us and do their bit. So there we are, got that conduit on the pipe. And now we'll demonstrate how to use your compression fittings. So this is a Eurocone fitting. Obviously we're using a 16mm pipe, so it's a 16mm Eurocone that we'll be using. So the first thing to do is put your nut over the pipe. The nut is essentially going to be the bit that holds the pipe onto the manifold. The next part of the Eurocone fitting is the split olive. This then slides on next, and then the insert section of the Eurocone functions similar to how a conventional reducer would work in plumbing elsewhere. So you've got 16mm on this side, and this is tailored to take the fitting on the manifold. So once you've got the Eurocone fitting hand tight, grab yourself just a normal spanner or an adjustable wrench, grab hold of it and just snug it up. So now we've got the pipe connected, let's talk about some of these other bits and bobs that I've got with me that are part of the manifold assembly. So the first thing is your ball valves. So what these are essentially is just an isolation valve. So you can see just opens and closes like an isolation valve. So these come in the box with a 1-inch fibre washer. Now this is what makes the seal between the valve and the manifold, and provides a bushing to stop the metal on metal contact, which you don't want. So put our fibre washer in there. As you can see, this is a blue tap, so this goes on the return side of the manifold. And we simply just screw that on there. Hold the valve steady. So on this particular new build, the next thing to connect would be your pump and mixing valve unit, which I've got just down here by the side to demonstrate. So this manifold has 400 meters of pipe connected to it approximately. So what you don't want to do is put the strain of circulating that on your boiler pump. So the underfloor heating manifold has its own pump that handles the circulation of the underfloor heating system. So you'll notice you've got the pump on the top, and this at the bottom is the blending valve. So this will mix down your incoming boiler temperature hot water down to anywhere between 40 and 50 degrees. Most underfloor heating systems, if they're running efficiently, will run between 40 and 45. And that would simply just go there. But in this particular scenario, we haven't got any electrics yet. The boiler's not installed, so we're not going to install the pump at this stage. But because we have the ball valves connected, that will still enable us to do a pressure test. So that's this side of the manifold now taken care of. We're going to move on to the other side. So to fill and drain the system, you need a set of fill and drain valves. So these are similar in terms of how they connect to the ball valves, because they're attaching to the same size threads. The manifold has a 1-inch male thread on both sides, all the way around. So again, in the box with your fill and drain valves, you'll have a 1-inch fibre washer to again just make that seal and to bush that metal on metal contact. So we're going to put the flow side on. You'll notice that the flow side has an automatic air vent, and this is just to help enable smoother running of the system and prevent things like air locking and just air in the system in general. So I'm going to just attach this now. The pressure gauge and the automatic air vent are optional upgrades, but they're ones that we highly recommend. As I said previously, the automatic air vent helps to ensure smooth running of the system, and the pressure gauge attached to the return side is a very helpful diagnostic tool, and just it's easy at a glance without hooking up an external pressure tester to see what your system pressure is at any given time. We've now got everything connected to the manifold. All of the attachments are on the manifold as well. So we've now got a hose pipe connected to the fill side of the drain valve, and also onto the drain side of the fill and drain valve assembly. So at the bottom of the fill and drain valve, there is this fitting, which can be either removed and replaced with just a standard hose lock fitting, as we've done at the top here, or a simple normal garden hose can be attached directly onto the barbed fitting at the bottom. So what we're essentially going to do when we're filling the manifold is we are replacing air in the system with water. So To do this, we remove the caps from our flow meters. The manifold will come with the flow meters closed. So to open the flow meters, just turn them anti-clockwise and you'll start seeing threads. There we are. So I've now turned all of these flow meters are fully open. So what we're going to do is we are going to fill each circuit and purge it of air individually, one at a time. Fill the first loop. We're going to leave all of these flow meters open to allow water in from this side, and to ensure that once all of that circuit is fully topped up and all of the air has been removed, we can then tighten down here to close this circuit, and we will open the next and we'll fill this circuit, close this down, open the next circuit, and so on. So we're just about to start now. So we're going to fill this, open up the water supply. That's going to start filling the circuits up. We will hear some air coming out. It's like hissing and spluttering. And we know that the circuit is fully filled and all of the air has been purged once we're getting a steady stream of water with no burbling sounds or no air bubbles visible in the bottom of our bucket. So we're just going to start with the first circuit. So we open up the first circuit on the bottom here. We'll ensure all the others are closed. And then so as you can see, we've got the air bubbles. Now that one is done. So we've now purged the system of air, so we're about to start pressure testing. So to do the pressure test, we first take our pressure tester, fill the reservoir with water up to the line. So before we connect this to the manifold, we need to purge the air that is sat in the hose. So to do this, we simply open the connection and pump until we see water coming out the other end. And now we can see as I pump, the stream coming out the other end is uninterrupted. We know there's no air in the hose, so we seal this back off. We can now connect this to our manifold. We're connecting onto a 3/4 to 1/2 inch adapter. Now, all of our flow meters are open and all of the circuit isolation valves are also in the fully open position. And now we can let the pressure in. We're going to carry on up until we get to 4 bar and then we're going to stop. And what we're hoping for is that it holds steady with no major fluctuations for about 15 to 20 minutes. So I'm happy that the pressure in the system is holding steady. We're now at a stage where we can disconnect the pressure tester. So first of all, we need to remove the pressure from the pressure tester. Simply open this valve, unscrew this, you'll see the pressure gauge drop to 0. We now know there's no pressure in the hose. We can safely disconnect using our spanner. We're going to leave the pressure in the manifold because the kind of pressure that we've pressure tested it to is what you would typically want the pressure in the system to be whilst the screeding of the floor takes place. So when the screeding is taking place, you want to sporadically check your pressure gauge to ensure that no damage to the pipework has occurred. If the pressure drops, you could have a problem. the manifold installed, filled and under pressure ready for the screeders, that's going to complete our installation of the high output water system. For more information on this product and indeed our full range of products, please click the link in the description.